so we got to the partitioning part yesterday. And so the first point that gets written down, okay, let me back us up a little bit. So we're doing the trapezoidal rule, okay. So the y0 is the first point that's plugged in, okay. So that would be this endpoint here, okay, getting plugged into this equation. So y sub 0 is this first point, so 1 squared. So that's where this part came from. Okay, this was because that was the x squared part. So basically y of 1, which was 1 squared, which is 1, is that part. Then over here, this point that's going in, the final endpoint is 2. So y of 2, in this case, was 2 squared, which is 4. So 4 is going in there. So those ones, the first and last one don't get multiplied by 2, but the other ones do.
They get squared. Or, well, no, they get whatever is.
It's whatever the function is. Yeah, this case is just squared.
Yeah, okay.
But the middle ones get whatever the function is times 2. Now, I don't know this for a fact, but I would assume that to an extent it has to do with the fact that it's partitioned and this point is there twice. But I don't know that for a fact, so don't quote me on that. Could just be purely random. Okay, so now we need to multiply all this through. So this is going to be 1/8 times 1 plus, and I'm not going to reduce this stuff because I want to keep that common denominator. So I'm actually going to write this in terms of 16 over 16 instead of 1 so that I get that common denominator, make it easier. So 16 over 16, and then 50 over 16, 72 over 16, oh gosh, 98 over 16 plus over 16.
64.
Thanks. I was going to get there eventually. So now I can add all those lovely things up. Ethan's like the pro at doing things in his head.
What? Well, that part is 300 over 16. I'll break the desk. Let me move.
Why are you doing that?
And then dart frack that puppy.
Dark frack, that's a thing. I don't like that.
So that the answer's in a fraction?
What?
I know, but
Yeah, but like, what's so fast? I don't know.
Where's dark frack?
Math.
math and then fraction.
Why is it called dark frack?
Dart.
Dark.
This thingy.
75 over
Like
30.
the arrow
I thought
looking
you were
thing.
saying dark.
75 over 32.
75 and 32, is that what you got?
Yeah.
Okay.
And then as a decimal, what is it? Just for curiosity's sake.
2.3.
Okay, now use NINT and plug in the original here to NINT and see what you get. No, it's a 1.
What?
From 1 to 2.
Yeah.
Where is an eye?
There's a little dot up there.
Yo, I got a number kind of close to it.
What'd you get?
2.3 repeating.
So this is the exact value, okay? This is our, basically it's like an approximation. So if we wanted to do and see what the error is for this, which you don't necessarily have to do unless they ask you for it, but just so you can see it, we would do this 2.34, whatever the number was, minus the 2.33 repeating number. Divided by I think it's just divided by the number that it's supposed to be. Yeah. Divided by the 2.33 number. So whatever number it's supposed to be goes on the bottom.
Is there a way to like make a number repeating on a calculator?
I just usually do like 2.33333 and then stop, because usually that's enough.
Me personally, I got 0.0029. I rounded.
Me personally, I also.
Me personally, I also got that. We need to put those balloons out of their memory.
Yeah.
Give me one.
Oh, gosh.
Oh, one time, I almost like died.
What?
Huh?
Because, like, I was sucking a balloon out of the helium. I was sucking the helium out of a balloon, right? And then,
How did y'all put this number in? Because that's not what I get when I do this problem.
You also get .0044.
Yeah.
And that's what I got.
Okay.
I didn't say anything. I assumed they were right.
Oh, question.
And
I
if-
Did you subtract these two numbers, hit enter, and then divide?
Yes.
Yeah.
no, I put it all together.
That's what I did.
Or did you put it in a fraction bar?
I put it in a fraction bar.
I didn't do that. I just
I didn't put it in the fraction bar either.
I subtracted and then divided.
What mode do we have to be in? Does it matter?
I don't think.
Shouldn't matter.
Yeah.
How many threes are we supposed to put? The 2.33?
I know why. If you use this rounded number, you don't get the right answer.
That was the round.
That's why I put the ... We needed to not use the rounded one.
What were we actually supposed to?
It was 2.34375.
Yeah. Christian, I'm assuming you used the full number.
Yeah.
You said 3434375.
34375.
Anyways, back to my near-death experience. Okay, I was
No.
sucking the helium out of a balloon, but like Garrett, like pushing down on the balloon, and like I took in so much helium and I blacked out through the head
explains a lot.
I have no memory of it, but
Well,
I mean, you just explain the whole thing, so obviously yes and no.
yeah, I was explaining what I was told what happened to me. I don't remember. I just remember they're like forcing down a bunch of helium down my throat.
Okay, so we had 0.446% error on this problem. And just for reference, this is an overestimate because the number that we got for the trapezoidal rule is bigger than the number we got actually by putting it into the NINT thing.
Why is it an overestimate? Yeah.
Because the number we got from trapezoidal rule is bigger than the exact value. Okay, so some examples from the homework problems. Use the trapezoidal rule with n is equal to 4 to approximate the value of the integral. Use the concavity of the function to predict whether the approximation is overestimate or an underestimate. Finally, find the integral's exact value. So, this will be a review of concavity because we haven't done that in a hot minute.
I don't like
All right, 2. We've got the integral from 0 to 2 of x squared dx.
What's the value we're using?
Huh?
What's the value we're using?
What do you mean? What's the value we're using? Oh, like the interval?
Yeah.
Well, it's from 0 to 2.
Oh, okay.
So yeah, whatever. If it doesn't, like, it might not necessarily give it to you separate. It might just be in the problem and you'd have to pull it from there.
You said n equals 4, so you have to
Yeah.
have 4 somewhere else?
Yep. So n equals 4. We're on the interval 0 to 2. So first and foremost, I need to find h. How do I find h?
B minus A divided by M. So 2 minus 0 divided by 4, which would be 1 over 2.
So h is 1/2. On this one, I'm going to show you kind of the way that I usually do these problems with setting up the little table. Like, it's a tiny table that just makes it a little bit easier than how I, like, wrote out every single one up here. Just so that it won't take up so much space and mathematically it'll be a little easier. Now, if you got a more complicated problem, you might not be able to do this method as easily, so you might want to do it, this way. But, so I'll do a little, like, XY table here. So, the first one is 0. Okay, the first endpoint. We're in increments of 1/2, so that means I'm going 0 to 1/2, so 1/2 would be the next one. I would be 1/2 to 1, 1 to 3.5, then 3.5 to 2. So now I know that at these two endpoints, these are just whatever getting plugged in gives me. But then the other ones, the ones in the middle, get multiplied by 2 for the trapezoidal rule. So 0 squared is 0. 1/2 squared is 1 squared is 3/2 squared is, and 2 squared is. So now I've basically, in short, done what I took, that much space to do on the last problem. So now I just need to plug it in for the trapezoidal rule part. So T is equal to H over 2, right? Verify it's the right one. Where is it? There it is. Yep. Just want to make sure I don't do it wrong to begin with. So 1/2 over 2 times the first term is 0 plus 2 times 1/4 plus 2 times 1 plus 2 times 9/4 plus 4. What's 1/2 divided by 2?
2. Oh, 4.
1.
1/4. You did it the other way. All right, so then over here, 0's going away. 2 times 1/4 is 1/2. 2 times 1 is 2. 2 times 9/4 is 9/2 plus 4.
Can we rewrite 4?
Well, I'm going to make your life easier. What's 1/2 plus 9/2? Which is 5 plus 2 plus 4 is
Well, that's 11.
Wow.
11.
Wow.
So 1/4 times 11. Somebody give me that decimal.
2.75.
So that would be the approximation from the trapezoidal rule. Now we're going to use concavity to determine if it's an overestimate or an underestimate. So how do I determine concavity?
Take
The first
the
derivative
second.
test.
You need the first derivative and then the second derivative test.
So I'm going to do the first derivative and then the second derivative. So what's the first derivative of x squared?
2x.
What's the second derivative of
2.
So, what do we know about that?
It's a constant.
Which means, well, in relation to 0,
It's bigger
It
than
doesn't
0, so
it's greater than 0.
concave. Wait. That means it's a overestimate.
Yes, it's an overestimate.
So if you were to get a negative number, it would have
An underestimate.
been. Does that go for any problem, or is it just because 0 was was like the beginning of the
Well,
end?
we compare it to see if it's positive or negative. That's the only reason it's 0. But technically speaking, when you get to the end of the problem, you can just do what we did up here and see if it's bigger or smaller and determine if it's an over or an underestimate. So unless it like forces you to do it, I mean, I would probably do this way because it's easier, but
Yeah.
all right, part C says find the integral's exact value to check your answer. So the integral from 0 to 2 of x squared dx, we're going to do this one by hand instead of with a calculator. What is the antiderivative of x squared?
I mean,
1/2.
Other way.
1/3
x.
x cubed.
1/3 x cubed. So remember, we add 1. We haven't done this in a while. We add 1 to the exponent and then figure out what we need to put in front to cancel it out to get us back where we started. Evaluated from 0 to 2. So we have 1/3 times 2 cubed minus 0, because when you plug in 0, it's all going to go away. So what is that?
8.
And somebody tell me what that decimal is.
2.67.
Yeah. So then, if we were going to do it the way that we did the error part earlier, we could do, it doesn't ask us for this, but we can do it. 2.75 minus 2.66 repeating, divided by 2.66 repeating.
Was 2.75 a rounded number?
No, it shouldn't be.
It was just
Did you get enough sixes, Christian?
0.0312.
So that means there was a 3.12% error.
But it did not ask for error in this problem, correct?
Correct, it did not. Let's do there's stuff I want you to see in both of these, so I guess we'll do both. For the integral from 1 to 2 of 1 over x dx. So again, with this problem, n is still 4. I think aside from the word problems, I want to say all the problems are n is equal to 4, like Simpson's rule and the trapezoidal rule problems. And our interval is 1 to 2 from the dimensions here. So I need to find h.
It's 1.
It's
2 minus 1 over 4, 1/4. So then I'm going to set up my table. So I've got the first number is 1. Then I've got 1 1/4. Got 1 1/2. 1 3/4 and 2. Now, it might be beneficial to think about these in terms of their improper fraction when plugging them in. It might make life a little easier. So if I plug in 1, I get 1. I would say plug in 5 over 4 instead of 1 1/4. Just 4/5. I'd plug in 3/2 instead. 2/3. Plug in 7/4. Then plug in 2. 1/2. Are we tracking where we got all those from? Everybody good? It was 1 over a fraction, so we keep change flip. Got it. All right, so now we set up our trapezoidal rule. So t is equal to 1/4 over 2 times, so we have the first number, 1, plus 2 times 4 over 5, plus 2 times 2 over 3, plus 2 times 4 over 7, plus 1/2. So we've got 1/8 times 1 plus 8 over 5 plus 4 over 3 plus 8 over 7 plus 1/2. And at this point, I'd get out a calculator. That's a lot of fractions. And I would say go out to like 3 or 4 decimal places on problems that do that before you round so that we don't end up with the issue like we had on that first one. I would go at least 3 decimal places.
I got. Well, I multiplied the 1/8.
Yeah, that's fine.
I got 0.69702.
So then, with this one, the concavity test would not be my choice for finding out if this is an overestimate or an underestimate. I would wait and see what the real value is, because concavity test is going to be harder for this one, because what kind of a derivative am I going to be dealing with?
Product. Derivative. Chain.
Quotient.
A quotient rule, right?
You
I
said
mean,
that
in a
was-
sense, because the derivative of 1 over x, we can convert that to be like x to the -1 and then take the derivative. It's not exactly directly a quotient rule, right? But the process to do it in terms of finding where the zeros are and doing a table and all that is going to be a lot more work. So I would personally not do the concavity test for this one. I will probably on like the quiz or the test tell you to pick, like, just tell me if it's an over or underestimate based on, you know, if you want to use concavity or you want to use the other thing and check and see what it is. But we'll skip that for a moment and do the finding the actual integral. So from 1 to 2 of 1 over x dx. Do y'all know what integral or what the antiderivative of this is? Yep, ln of x. So ln of x evaluated from 1 to 2. So the ln of 2 minus the ln of 1. What is the ln of 1?
0.
0.
It would be 0.69314.
So based on that, is this an over or an underestimate?
Overestimate.
Overestimate. I'm not going to do the error for this one because they don't ask for it, but all right, let's do one more of these that has a trig function in it just so we can see what's happening. 6, the integral from 0 to pi of the sine of x dx. So n is 4, interval is 0 to pi. So what is h?
Pi over 2.
Yeah.
4.
So pi over 4. So table.
So which ones can you not do a table on?
You can do it for all of them. I just
Oh,
didn't
okay.
do it. I just didn't do it yesterday because I was just showing you, like,
That makes sense. Okay.
I was trying to show you exactly what was happening in each step, but I'm like, once you see it once, you can just do the little table thingy. And otherwise, I would have just been showing you, like, random numbers thrown in, and you would have been like,
That makes sense.
what is happening?
Yeah.
So we start with 0, pi over 4, pi over 2, 3 pi over 4, and pi.
Like this one.
What is the sine of 0?
Oh, that's easy. That would be
0.
0.
Cool, I got that.
What is the sine of pi over 4?
Root 2 over 2.
Root 2 over 2. What's the sine of pi over 2? What? Yep.
Yeah.
3 pi over 4.
Root 2 over 2.
Root 2 over 2. And of pi.
0.
Alright, so notice the first and last terms of my trapezoidal rule are both 0. So that means everything that's going in the parentheses is going to end up being 2 times something. I'm going to write the zeros in so you see it if you go back and look, but you wouldn't normally need to write the zeros in because they're just 0. Okay. So, trapezoidal rule. So we've got pi over 4 all over 2 times, again, I normally wouldn't write this, but 0 plus 2 times root 2 over 2 plus 2 times 1 plus 2 times root 2 over 2 plus 0. So I've got pi over 8 times, now notice 2's cancel, 2's cancel. So I've got 2 plus 2 root 2 and then at this point you can use your handy dandy calculator and get that number.
Plus 2 root 2 times 4.83. What I got for that value.
Did you multiply by pi divided by 8? Oh, okay.
No,
Just-
not
it's
yet.
just
I was
doing
just
that
doing
value.
you.
Sorry.
I was like, what?
And then the multiply would be 1.8961.
All right, I'm going to show you something about this problem if we were to use concavity. Again, I would probably, for the sake of it, ease, I would probably not do the concavity method most of the time because there's, other ways to do it. But I want to show you something about concavity with this one. What's the derivative of sine of x?
Cosine of x.
What's the derivative of cosine x?
Negative sine x.
Now, I'm looking to see is this less than or greater than 0, right? To see if it's positive or negative to determine if it's an overestimate or underestimate. Now, do you just know off the top of your head, this isn't a whole number like 2 was earlier, but do you know what this is going to be?
Underestimate. Wait, no?
No, right? Because there's an x here and we have no idea what x is.
Yeah.
Okay? However, we were told that it's on this interval from 0 to pi.
Yes.
So what does sine have to be everywhere from 0 to pi?
Positive.
Positive. But
There's a negative sign. Right?
there's a negative here,
So it's going to be negative.
so it's going to be negative. So this is less than
Less
0
it's an underestimate.
for x being an element of, okay, or x being in the interval 0 to pi. Okay, which, yes, makes this an underestimate. Now, we could still do it the other way. Totally fine, but I wanted you to see this about this rule in particular. So then, doing it by hand, from 0 to pi of sine of x dx. What is the antiderivative of sine of x?
Oh, negative cosine x.
Negative cosine x from 0 to pi. What is negative cosine of pi? Yeah, so cosine of pi is negative 1 times negative. This is going to be positive 1. Now it's minus negative, so plus cosine of 0. Cosine of 0 is 1, so this is equal to 2. Which is what compared to this? Well,
Wait.
2 is bigger than this, right? So that means that this was an underestimate. Okay, the trapezoidal rule was an underestimate for this particular problem. So that would be the other way to look at it. in terms of that. So we'll look at a word problem tomorrow with this stuff, and Simpson's rule will be tomorrow. We should be able to wrap this up by the end of tomorrow. So we might just do a small quiz on this.
Okay.
TBD. I don't know. Might wait and combine it with chapter 7. I need to look at it, but